Okay, so in 3.2, we're going to still be doing the same thing that we did in 3.1, where we were solving systems of equations, where we've got two equations and two variables. This time we're going to look at two methods other than graphing that you can use to solve. The first one is called substitution, and if you want to go through and write the steps here. You might pause it for a second because I'm just going to read through these quickly. But what you're going to do is solve one equation for a variable. Try not to get fractions, you'll thank yourself. Plug that into the other equation and solve. So let's look at an example. So what I'm going to go through and do is I'm going to solve for a variable. I think the easiest variable to solve for is that y right there. I'm actually just going to move it to the other side of the equal sign because that'll make it positive. So y equals 3x. Now once you've solved for a variable, take what that variable equals and plug it in into the other equation. So y is 3x. I'm going to plug in 3x for that y right there. Now, here's the purpose of doing that. See how now we have everything in terms of x's? That gives us enough information to go through and solve for the x. All right? So I've got 13x equals 26. Divide by the 13. And x is 2. So that gives me my x value. Then to get my y value, plug the x into the equation that I solved for. So y is 6. So x is 2, y is 6. I'm going to write it as a point. 2, 6, x, y. Okay, so this is solving by substitution. Let's do one more of these. Okay, so looking at this, I'm going to pick one to solve for that doesn't get messy. So I'm going to pick that y right there. So I'll have negative y equals negative 2x plus 7. If I divide through by the negative, y is 2x minus 7. Two negatives make a positive. Okay, so I'm going to take what y equals, and I'm going to plug it in for the y in the other equation. So I have 4x plus 3y, and y is 2x minus 7, equals 4. And I'm going to solve for my x. So do your normal solving stuff. Go through and solve for the x. Okay, so I distributed out to combine like terms. And continue solving. Alright, now not y'all's favorite necessarily because I gave y'all one that's not super nice. This reduces to 5 over 2. So my x value is 2.5. I'm going to leave it as 5 over 2 to plug into my other equation. Alright, so my x is 2.5. To get my y, I'm going to plug it back in up here. Now, like I said, I'm going to use the improper fraction because I think it'll be easier. Alright, so that was nice. The 2's cancel. And I have 5 minus 7 is a negative 2. So my answer is x, which I'm going to write it, instead of the improper fraction, I'm going to write this mixed number, negative 2. Okay, so take things step by step. If you take them step by step, you'll probably be okay. Usually when people run into problems, it's because they rush. Okay, so let's look then at our second method, which is called elimination. Same thing, if you want to write down these steps, you might pause it right here. So here are our steps. We're going to add to eliminate a variable, multiply through if you need to, solve for a variable, and then plug in. So let's look at what that looks like in a real problem. So what we're looking to do is eliminate a variable by adding down. So see how if I add down here, I've got negative 2y, positive 2y, those cancel out. That's good. That's what I want to happen. So here I'll have 5x equals 10. X equals 2. Okay, so I've got my x value, and then I want to pick one of those, it doesn't matter which one, to plug my 2 into to get my y. So I'm going to pick the second one just because the numbers are a little bit smaller, and go through and solve for my y. So move that 2 over, divide by the 2 in front of the y. So 1/2. Now again, I'm going to write it as a point, so 2, 1/2. Now my preference, most of the time, I choose elimination. I like this method. I think it's a little bit easier than substitution personally. I think it usually goes a little quicker, so this is my method of choice. Now it's a little bit of a personal decision, you know, some people prefer substitution, so. Okay, let's look at one more. No, actually, we're going to look at two more. So looking here, my 4x's will not cancel because this one's positive, this one's also positive. So what I'm going to do is I'm going to multiply this through by a negative. And I can do that as long as I balance both sides. So I'm going to just put it in red. So when I distribute out that negative, here's what I get. Now that 2 became a positive because 2 negatives make a positive. Now that allows me to add down. So I had 9 minus 6 is 3y equals 3, y equals 1. And then same thing, plug into one of the equations. I'm going to pick the top one. You'll get the same thing, so it doesn't matter which one you plug into. Okay, so I have 4x plus 9 equals 1. Subtract my 9. So 4x equals, that looks like a 4, but it's really a 9, negative 8. X equals negative 2. So my answer is x and then y, negative 2, 1. And let's look at one more of these. Now, this time, see how neither of these cancel out? This might be a situation when you choose to do substitution, though I do think substitution could be messy here as well. If you don't have anything that cancels out, what you're going to need to do is multiply through each of these equations to make them cancel out. I'm going to focus on my x's. I'm going to focus on making them cancel out. So I want to think about what I could multiply each of them by to get the same number but one positive, one negative. I'm going to multiply this one by 5. That'll give me a 15x right there. And I'm going to multiply this one by a negative 3. I need it to be negative so that I get negative 15x. Okay, so let me do that. So I have 15x plus 35y, this is the top one, equals 15 times 5 is 75. And then multiplying here, negative 15x minus 6y equals 12. And then I'm going to do my elimination. I set it up to eliminate. So I'll have 29y and equals 87. Divide by that 29 and y equals 3. Okay, so I have my y and then I'm going to plug it back in. Take your choice, but probably pick one of the original two, not one of the ones you've multiplied through. The numbers will be smaller, it'll make it easier to deal with. I'm going to pick this one. And go through and do your number crunching. You should be okay, I think, if you get to this point. Okay, so my answer then is negative 2, 3. Remember, you want to make sure to do x and then y. Okay, now the last thing that I want us to look at is our weird situations. You will remember when we were graphing in 3.1, we had our weird situations where either the lines laid right on top of each other and then your answer was all of the points on that line, or you had lines that were parallel, and in that situation you didn't have an answer. The answer was no solution. I want you to see what each of those look like in this kind of setup. So here's our first weird case, and I'm going to start by doing it with substitution, and then we'll do it by elimination. I want you to see what they look like. Okay, so I'm going to solve for my y right there. So I have y equals 2x minus 3, and then I'll plug it in for the y in the other equation. Okay, so simplify down, distribute out that negative. Now, here's where you know we're getting to a weird case. See how those x's cancel out and you just have 3 equals 3? When the x's cancel out, you know you're going to have a weird situation. Now, see if you would agree with this train of thought. It doesn't matter what my x value is. It cancels out anyway and leaves me with something that's always true. 3 equals 3. This is where the lines lay right on top of each other. Here's your answer. Every number that lies on those lines. Now you can pick either of these two that you want to put right here. If you move them around, they're actually the same line. Okay, and then let's do this by elimination. So I'm going to try to eliminate the y's. Oh look, they already eliminate. Here's the problem. The x's do as well. Even these numbers do. So I end up with nothing over here and nothing over here. So same thing, my x's and my y's canceled out. I'm left without a variable. You want to look and see if it's true or not. If it's true, it's everything that lies, those lines are the same, it's everything that lies on those lines. You can pick the equation. If you were to put them in y equals mx plus b form, they'd be exactly the same. Okay, so let's look at the other one. Okay, so same thing. Let's just start with elimination on this one. So I'm going to start with elimination because I'm running a little bit short on time. Look at what happens here. See how these both eliminate, but this one doesn't? So I have 0, nothing on the left-hand side, equals 12. Now, same thing, all of your variables canceled out, but you're left with something that's not true. 0 does not equal 12. If you're left with something that's not true, that's when your answer is no solution. You can write out no solution. You can do the empty set thing. Now I'm almost about to go over on time, so I'm going to skip this substitution one. But the same thing would happen. You would go through and you would end up with your variables canceling out, and you would have something that would not be true. And that's the same, it looks exactly the same in substitution as it does in elimination. All right, lots of stuff in this section, so go back and watch some of these examples again if you need to.